Good afternoon, everyone. So this was the point of discussion yesterday, the relation between IE, electronic configuration, and atomic radius. Very close relation. So all three are interdependent because from the electronic configuration, we will come to know how many shells are there, how many orbitals are there, and from the atomic radius, we will come to know how much is the size. So these two in turn have relation with the ionization enthalpy. So more the number of shells, less is the IE, or more the atomic radius, less is the IE. So this was the relation we have checked yesterday. Okay, and one more point, for every electron there are two types of uh, forces. One is the force exerted by the nucleus on electron, that is called attractive force. Other one is repulsions which are there within the atom, that is inter-electronic repulsions. Okay, so the combined effect of these two will decide how much energy is required to add or to remove electron from the neutral atom, so that neutral atom converts into an ion. Okay, right. So this was the point of discussion in our previous session, and accordingly all the same shielding effect, that is covering of outer electrons by the inner electrons, and this is second enthalpy, that is electron gain enthalpy. So enthalpy related to enthalpy is related when electron is gained by respective atoms. Okay, so that they convert themselves into anion or the negative ion, and factors affecting electron gain enthalpies. So under what ground, under what circumstances we feel easy with what is, we are given chance, we are given provision to add electron, so that atom accepts comfortably, happily, because ultimately happiest state is the most important state for everyone. So for the atom, happiest state is what? Stability. What is stability? Least repulsions. Okay, let's go for the least repulsion. We cannot avoid, repulsions are there all the times, but let us go for the minimization of the repulsions. Disturbances are there in the life, I agree, but we will go for the minimum disturbances. If at all disturbances comes, so we will cope up, we will manage, so that we will go for the next day, because we have to reborn every morning, no? So the moment we get up every day, so with a fresh thought, with the fresh resolutions, with the fresh plannings, we will get up. In the same way, here also, let us go for the minimum repulsions or minimum disturbances, so that we go for the maximum stability. That is the main theme behind the chemistry. So in chemistry, these 2 points you remember: minimum repulsion, maximum stability. When the minimum repulsion is there, it is minimum energy, because every system wants to go to the least energy state. So everybody likes least energy state. Accordingly, we will go for the that only, that is least energy state or the maximum stability state. So accordingly, we go for the atomic radius, nuclear charge, electronic configuration. All those factors are there on which electron gain enthalpy depends. Now variation along group means from top to bottom. So top to bottom size is increasing, so it becomes easy to add electron. Okay, therefore we go for the larger negative value for electron gain enthalpy. Whereas when you move from left to right, that is in a period, variation is, trend is, size is either constant or decrease in the size. So decrease in the size, what happens? There are two factors. Factor number one, nuclear charge will have control over the electrons. Then second is what? As the size is decreasing, so in the small size, electrons have to adjust. So thereby they may experience what? Inter-electronic repulsions for the incoming electron, the extra electron what we are adding. So these two factors will decide so whether to accept easily or with difficulty. Accordingly, we will supply energy. So While supplying energy only, you will come to know. If you are supplying more energy, then think that it is difficult to add. If you are supplying less energy, it means we are what adding electron easily. So all those will happen when we conduct experiment. There we come to know with what trouble, with what difficulty, with what hurdles. So we face to add electron. Okay. So all those factors are there when we see variation in a period and in a group. This is the period, and this is the data, main data we have seen. So in the halogene, you see yesterday our friend Raghavendra clarified why chlorine has got a larger value of negative value for electron gain enthalpy. So though the fluorine is the first member, it is the best electronegative what element on the modern periodic table, but still it is, when compared to the chlorine, it is having less negative value for electron gain enthalpy. It is just because of what inter-electronic repulsions due to the smallest size and the modern electronic configuration. So chlorine will experience very easily in accepting electron compared to the fluorine. This we have made clear in yesterday only. Same point is applicable for the oxygen and the sulfur, those two. So now if you come to the extreme right side, helium, neon, argon, krypton, xenon and radon, we don't have negative value for the electron gain enthalpy. Rather, we have the positive value. So positive is still difficulty, because if you go lesser negative value means what difficulty, again still less, again still less, go to zero, go to positive. That means the values what for the electron gain enthalpy for the noble gases are the 18th group. What we say is zero group according to the old convention. It is in the positive, indicating that very difficult to add. Okay, even if you see the ionization enthalpy for these, they also difficulty. So difficult to remove, difficulty to add. So that's why they are called as chemically least reactive. We don't have any what what special test to add and the remove electron. Okay, so just for a while, excuse me, I will come back within a minute. Okay, let us start once again with the noble gas. So already told, positive means not ready to accept. Electronegativity. This is the property uh, to withdraw what shared pair of electrons. See, difference is there here. Difference between electron gain enthalpy and electronegativity is electron gain enthalpy is adding electron to the atom, neutral atom. But for electronegativity, first bond has to form. Once the bond is formed, then it will withdraw a shared pair of electron. For example, in the case of SCl, there is a bond between H and the Cl, that bond. Okay. So first bond has to form, bond is formed. After forming the bond, now there are two electrons between the H and the Cl, because H will give its electron and the chlorine will give its electron, and in between they share. After sharing, covalent bond is formed. Now bond is formed. After forming bond, what they think, when we compare the electronegativity power or the ability of H and the Cl, so Cl is more electronegative. What Cl says, I will withdraw shared pair of electrons towards me, so that they spend more time towards chlorine only. So that means what? That means the shared pair of electrons, that means electrons which are there between the H and the Cl, which are responsible for the bond making, for the bond formation, those two electrons lie near chlorine, because chlorine is more electronegative. So electronegativity is the ability, or it is a tendency of an atom to withdraw shared pair of electrons. I am using the word shared pair of electrons. So because of this, electron cloud is lying near chlorine. And because electron cloud is lying near chlorine, chlorine gets a partial negative charge. And because hydrogen is losing the electronic cloud to some extent, it is taken as what? It gets the partial positive charge. Therefore, whenever electronegativity difference is there, okay, that time poles are created. What type of poles? Electrical poles, charged poles are created, temporary poles are created. Okay, so one pole is what? The one which is losing, that is H in this case, and the other pole is what? Negative, that is one who is accepting the electronic cloud. So here H gets the partial positive and Cl gets the partial negative, and this is called what? Dipole or polar. When the poles are created, the molecule is called what? Polar. But in the case of H2, in the case of Cl2, where both atoms are similar, what is Cl2? Cl2 is a molecule. So between the two Cl, bond is there. There also two electrons are there. But those two electrons which are there between the two chlorine atoms in Cl2 molecule, both are Cl, no? Both have same ability to withdraw. So then where the electronic cloud will spend time? Exactly in the center. Because both are similar atoms, both are similar withdrawing power. That's why neither electron cloud lies near that chlorine or this chlorine at exactly the center. So poles are not created there. Same in the case of hydrogen also. Both are similar atoms, H bond H. So the two electrons which are there between the two hydrogen atoms, they will be exactly at the center. So in the case of hydrogen and in the case of chlorine Cl2, poles are not created. Therefore, they are called as non-polar. H2 and Cl2 are non-polar, whereas the molecule formed by the combination of H2 and the Cl2, that is HCl, that is not a non-polar. It is a polar. Why? So here in the case of HCl, electronegativity difference is there. One is more, one is less. So one is more, that is chlorine. One is less, that is hydrogen. So the one which is more will withdraw. The one which is less will lose. Okay, it will cooperate. So the one which is losing will get the partial positive, and the one which is accepting will get the partial negative. So it is difference in the electronegativity will decide whether it is polar or non-polar. Okay, hydrogen non-polar, chlorine non-polar, SEL polar. Okay, so this is what this is called electronegativity trend. Okay, right. Now see this one, variation along a group. Now from top to bottom, when you move, okay, so what happens when you move from top to bottom? As usual, atomic size increases. When the size increases, electron goes far away. That means tendency of accepting electron decreases from top to bottom. That means what? Whether it is electron gain enthalpy or electronegativity. So both decreases from top to bottom. That means in the case of first group, that is from lithium, sodium, potassium downward, so electronegativity decreases. So francium is the least electronegative. That means what? It is more electropositive. When francium is least electronegative, so on the other part it means what? It means it is more electropositive. In the same way, if you see the lithium part, the first number, lithium is less, it is electronegativity is more. That means it is less electro positive or more electronegative. That's why if you see the chemistry of lithium, lithium compounds, lithium chloride, lithium carbonate, lithium bromide, all lithium compounds, they are covalent. Though they are extreme left side, though they belongs to S block. So though they are on the metallic side, but being a metallic, they develop electronegative character. So this we learn in the chemical bonding. Once again, there is a famous rule known as a Fazan's rule, where electrovalent compounds they develop covalent character, and covalent compound they develop ionic character. This all is there in the chemical bonding. Okay, so in the chemical bonding, soon after today's discussion starts, so we enjoy that also. So from top to bottom, the trend, the variation is what? Electronegativity decreases. So electronegativity normally we find where in the upper part of any group in the beginning. So first members are there now, they are better electronegative. And if you want to see the best electronegative character, you have to move towards right side, that to right top. So right top area is best electronegativity, and the left bottom best electropositivity. So this is the trend we have seen in a group. Okay, right. And values are given. Values are given. So 1.0, all the values are measured in terms of what? On the Pauling scale. So Pauling is what? Pauling is a famous scientist who has done research work on the electronegativity. His main topic of discussion was, research paper was on electronegativity. Linus Pauling from America. Okay, so and the brilliant scientist from America, Linus Pauling. So because of electronegativity only, we are all these we are discussing, whether it is electropositivity, electronegativity, metallic character, non-metallic character, atomic size, okay, and polarity, poles creation, dipole moment, and covalent bond, electrovalent bond. All these characters mainly depends upon what? Electronegativity. So therefore, we will salute the Linus Pauling, the great scientist. So there are many great scientists we have seen in the structure of atom. So to that list, one more scientist is there, that is Linus Pauling. So keeping his name because of his contribution, so we measure electronegativity on Pauling scale. Now variation along period. Variation along period. Same, already I told, from left right size decreases. So thereby metallic character decreases or non-metallic character increases. That means electronegativity increases. So from left to right, if you move in a period, electronegativity increases. The best example if you take is second period. Okay, lithium, I have shown here, lithium. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. You are moving from left to right. So see the values 1.0, 1.5, 2.0, 2.5, 3.0, 3.5 and the 4. Whereas in the third period, starting from sodium, sodium 0.9, magnesium 1.2, aluminum 1.5, silicon 1.8, phosphorus 2.1, sulfur 2.0, chlorine 3.0. Okay, and if you see what I told, uh, right top are the best electronegative, and values are the data is giving support to us. So it is support for our discussion. Okay, if you see the electronegativity, nitrogen and the chlorine, they have the same electronegativity 3.0, 3.0 on Pauling scale. Okay, so next is what? Next is it is oxygen 3.5, and among all the what elements which are there on the modern periodic table, if you see the electronegativity, it is fluorine which is highest. 4 is the highest value. All the electronegative values are less than 4. It is the fluorine which has got highest value for electronegativity. That means fluorine is the most electronegative atom on the modern periodic table as of now. It is the boss of electronegativity. So all other atoms less than 4. So fluorine will never become plus. Fluorine will never lose, it will accept electron. So positive what cation from fluorine is impossible. Fluorine will become negative only. So that's why all fluorides are what covalent. So whenever fluorine is there, no, sodium fluoride, lithium fluoride, all are covalent. So where fluorine is accepting the electron, and its electronegativity is the highest among all. Okay. So next place goes to bronze medal, sorry, silver medal goes to oxygen 3.5, and the bronze medal goes to nitrogen and the chlorine, where their electronegativity on Linus Pauling scale is what? It is 3. So all these data will help us in deciding the property also in future. He is the one, Linus Carl Pauling from America. Okay, Nobel Prize for Peace also. Award recipient for the year 1962, and award recipient for the year, he has got 2 times Nobel Prize. See, so what a great scientist. So in the year 1954 for the chemistry, his own field, and he was also working for the peace also, peace of the world, like our Mother Teresa. Is there? So great work, great scientist, not only for the science field, for the peace field also. Okay. So, and he has given one survey of the modern periodic table. So he has given some. So I have given error mark. So error mark indicates what? Error mark is increasing trend. Okay. So if you move from left to right, okay. So what is error mark here? Error mark is it is increasing. So if you move from left to right, electron affinity is increasing. Means what? Right side they love electron. What is affinity? Affinity is the love or attraction. They like. So the extreme left they like electron. That means what? You can add electron easily. That is the meaning here. So this error mark. This is top to bottom. Top to bottom increasing. What? Atomic radius. Okay. And here electron affinity from bottom to top increases because that means what? So left to right and bottom to top, right side. So they are the best electron lovers. Okay, right. So now you see this arrow mark, ionization enthalpy from bottom to top increases. Okay, atomic radius from right to left, it is what? Increasing. And here non-metallic character from left to right or diagonally, if you move, whether you move diagonally or from left to right, non-metallic character increases. That means you will find non-metals on the right side, especially right top. And if you see the metallic character, so whether you move from right to left or right diagonally, so what? Metallic character increases. So best metals will find left bottom. In between also D block is there. So there are also metals only, but the best metal will find left bottom, and the best non-metal right top. So this is a survey we have done, and accordingly the table is made. So from the survey only we will come to know that what. So where you will find the most electronegative, most from this we will come to know what type of bonding we expect. Okay. So when it see francium is electropositive, best electropositive, and fluorine is what? Best electronegative. When those two will come in contact with each other, so what we expect? Francium easily donates, fluorine easily accepts. So there is a transfer of electron quickly happens. So best electrovalent bond we expect between the francium and the fluorine. So francium fluoride is the best ionic compound. So by knowing the properties, we will come to know, right? So like that we will guess the properties. I think the topic, that is a chapter, modern periodic table or the classification of elements into groups and the periods, winds and the ends. Okay. So from tomorrow we'll start with a fresh mood, with a fresh zeal. The most important, the most fascinating chapter of 11th class, that is chemical bonding and molecular structure. Because there we enjoy variety of theories. Okay, different scientists have given their own way, so their own way of understanding, their own way of explanation. So we'll enjoy all those theories, starting from Kozel-Lewis theories, VSEPR theory, and VBT theory, molecular orbital theory. So only these are there for 11th class, and in the higher class we learn two more theories, and those theories are what? Ligand field theory, LFT, and the crystal field theory, CFT in short. So all those beautiful theories are there. Already work is done a lot in the field of chemistry. Okay. So only thing is you have to understand. So in tomorrow we will start chemical bonding chapter. Till then, any doubts are there? I will wait for 3 to 5 minutes. Aram se time is there. So you are most welcome to ask any doubt regarding today's session. Today Sushmita not joined. So I don't know Pallavi because I am unable to see slide is there. No. So Pallavi joined today. Ramlinga,
No, sir.
can you see the list? No, no. Okay, okay.
No, sir, she is not there.
Okay, okay, okay. And regarding Sushmita, she want to opt arts. Okay. So I told her I am hoping on you NDA. So why you are taking TC? She told, sir, by joining arts also I can join the armed forces because there is a one exam known as combined defense, so CDS exam. So for that we require graduation. whether it is a BCom, BA or BSc, any doctor, MBBS or BE. So any graduate can face a serious exam, and if it is qualified, you will go given an interview, and you are absorbed in the defense services. Okay, so that was her planning. So no problem, it is individual choice. So I think from today onwards, she will not be joining our class. She will take TC and will go for arts BA. So we, on behalf of entire 11th class, so we wish her best of luck in whatever field she selects, so that she will come out with a successful colors in future. So any doubt regarding the chemistry? So this is a piece of information to being a batchmate. So I given the information. So any information, any doubt?
Sir,
Yes, please.
sir, is there any unit for electronegativity?
Unit. It is Pauling scale only. Pauling scale. No unit. So normally we don't
Well,
use
sir.
1.0 Pauling scale, 2.5 Pauling scale. So Pauling scale in every unit I will not say no unit. It is a dimensionless or
Okay.
unitless.
Okay.
Because of his contribution, we are using his name. Okay, then anything, any other? If you don't have any doubt, I think we'll wind up. Ramlinga? Okay, Ramlinga, shall we wind up today this chapter?
Yes.
Okay. So tomorrow we start chemical bonding. Okay. So please come with a fresh mood, with a full of stomach, breakfast, whatever food. Okay. So please take a lot of food, fruits, energetic, enthusiastic, charming, cheerful, chemical, because it is bonding. So between me and
Sir,
you, so
sir,
it's
when will school start?
school. School. We are also eagerly waiting to see you all, but yet to get information from the Delhi. So Karnataka has given the green signal. Now it is Delhi has to give the green signal. So for other school, only one green signal. That is Karnataka state. But for our school, it is two green signals we require. So Karnataka government as well as the central government. Okay. Therefore, we are waiting. So things are materializing. Things are going smooth. So soon, I think soon, that soon is there now. Soon means what soon? How much we don't know. So soon we will be given intimation from the school side, so that you will join, and we will be happy to see you and to discuss uh, two-way better than WebEx. Now also we can discuss, but still that is a physical class, no? So Aram say. So hope, let us hope. Okay, then we will wind up the today's session with this small information. So tomorrow we'll start. So thank you, my dear students.
Thank you, sir.
Thank you. Thank you.